In this lecture, we will look at separate compilation spaces and namespaces. So separate compilation, basic idea is very simple. Just use .h files to declare and actually define a class, but then don't set up method bodies, so you don't have to set up method bodies in the .h file, and use a separate file, .cpp file, to have all of the function bodies or method bodies. Then we will take a look at namespaces. So namespaces we have used so far. We have used the standard namespace. So whenever we write programs that have any kind of I/O, that is input/output, using either the console or files, we would use you'd pound include I/O stream, and then also say using namespace standard std. That's what namespaces are about. It's somewhat similar to Java projects, but not exactly the same. Okay, there's a little bit more structure in namespaces. That said, we really don't need to use namespaces. It's a very nice concept, and it's especially useful in large projects. And we won't have anything quite that large. We will use a little bit of namespaces, not all that much. Okay, so what are we going to look at? Separate compilation, that is .h and .cpp files. There's also a lot of information hiding and encapsulation ideas that are behind the reasons for having .h and .cpp files, that is separate compilation steps. So we'll have .h files, or header files, and implementation files, which are the .cpp files. We will set up our own namespaces. We will use the keyword using, or the using directive, and then we'll see how to qualify names using the scope resolution operator, same as I think we've seen in the past for classes. We will also look at unnamed namespaces, which is something that C++ uses to replace various things that are still in use in C. So in C we use static things, and now in C++ we tend not to do that, and we use what are called unnamed namespaces. That's anonymous. I guess you could think of it as an anonymous namespace. And we'll also look at hiding some helping functions in namespaces, and nesting namespaces. That's just having a namespace inside a namespace. It's somewhat similar to the idea of a package inside another package in Java. So there are some similarities. It's not exactly the same. In Java, there's a tighter relationship between the name of a class and the name of a file, and similarly, packages are associated with directories in Java. That's not the case in C++. In C++, you, the programmer, can call the files anything. You can call the namespaces anything you want. You can nest as many levels as you want. Typically, that's, it's there, but I don't think we'll be using a whole lot of that. Definitely, you do want to be able to do separate compilation. That is, keep programs in different parts. You use a .h file and a .cpp file. That's the main idea. A big advantage in doing that is that you only compile what you need to compile, and then you do all of that separately, and then at the very end you do a link step. That is, you link all of the .o files. If you've noticed, we create .cpp files, and from that we generate .o files, and then at the very end we link that together with the file that has the main function, and you create an executable. Java is somewhat similar. We do actually compile each .java file separately, and you get a .class file. You don't actually do a link step in Java. That's just sort of understood that it'll happen at runtime. So in Java we interpret, we don't have an executable file, we just have a whole bunch of class files. And Java needs to know which class file has the main method, and then everything else is sort of linked together as you run. C++, you need to know all of this stuff beforehand. Let's take a quick example, and maybe this will make more sense. So let's say we don't have any files right now, and we create a main method, main function. So I'll go through the steps in Eclipse. The book doesn't actually use Eclipse. The book assumes that the book is independent of integrated development environments like Eclipse, and you can also you could just as well use the command line to do everything, and you can do everything using the command line. But for these programs, it's helpful to have Eclipse because the debugger is sort of built in. So start with a source file. I'm going to call it main.cpp. You have to give it some extension. We'll stick with CPP. Okay, so let's say we set up our int main, and then let's say we want to use cout, just print out something. Okay, and finish it then end line. And as you've seen many times before, to be able to use cout, you need two things. You need to #include iostream, and you also need to say either using namespace standard, that is, all these names like cout and endline exist in a namespace that's sitting out there, and you could say we are going to use that namespace. This is like importing everything from this package. You can think of it as a package, but it's a package that's spread out. So let's save this, compile, and okay. Always have this problem with Eclipse. It says that there's an error and then it actually doesn't. Okay, so all that's good. Now what we'll do is create a new class, and so you can do this manually. However, I think it's, for many reasons, in this one case, I think it's much better to actually do this through this new class wizard that Eclipse provides. Alright, and I had this before, so you could provide a namespace. Let's leave the namespace blank. Let's not use a namespace for this time around. And we will set up a class named, just call it A. Okay, as soon as you type in the class, you'll see that over here the header file is going to default to a.h. Source file is a.cpp. You want to stick to this notation, although there is no requirement in C++ that the class name has anything to do with the .h or .cpp file. You could call this anything you want. You could use lowercase. You could use anything. It's generally a good idea to use a class name that starts with an uppercase letter and use the exact same name for the header file and the source file. Okay, so there's going to be two files that are created. Right now we're not using namespaces. In the next step we will. So I like this wizard because it does a lot of things right, and it sort of puts you on the right track. So here is some comments at the top. You don't have to do much with that, but here's the thing. Notice where it goes. The class goes in between this pound if endif and define and before the pound endif. This, you can think of this as a if statement, but we will see what this is used for. Alright, so now we have set up a class. We have a .h file and a .cpp file. Now the .cpp file includes this .h file, a.h, which we just created. So this has all of the structure that we need. All right, now a quick word on what exactly this pound include does. So this pound include is something that is not really part of the C compiler, C++ compiler. It's part of the C++ preprocessor. And the preprocessor is not, I would say it's not all that smart. All it does is says if you want to pound include a file, and here in double quotes it means a file that we created in almost always, it'll always be in the same directory. If you want to include it from a different directory, you can. You just have to specify the path. Okay. Notice that it's different from the pound include for IOStream. For IOStream, we use the angle brackets or diamond brackets. That's because when you do that, you're saying look in the usual places where the system has .h files, and so eventually you will find something like a .h file, but it's going to be in a standard place, and it depends on the operating system. I'm using a Mac, and so it might be in different places, but on a Linux system it should be in some place like /user/include. This, however, should be in the same directory as this a.cpp. So you're saying in this a.cpp file, look for a file named a.h. Okay, and then what the preprocessor does is it takes the entire contents of this file, starting from the top, line 1, all the way down to the bottom, and mechanically or sort of verbatim includes the contents of that file right where this is. So if you can think of it, and this is a useful thing to do, is you can actually, if you want to try it out, remove this pound include and then copy this. So I'm going to use the copy command and then paste it right here. There's many reasons why you should not do this. The main one being that what happens if you change this? So now every time I change this, I got to copy it and paste it back. That's what the pound include saves you from doing. That is, you don't, every time you make a change in this .h file, you don't have to then copy and paste it. Putting this pound include essentially does that. It says, okay, I'm going to take everything from the .h file, put it into here. So the nice thing is that this wizard sets up all of this and it's ready to go. It should compile. Right now we're not using the A class in our main method or main function. Let's just do that. Alright, let's just do that. Check and make sure that compiles. It should compile. If you got an error message, whoops, like I did just now. Oh yeah, didn't compile. Here's the reason why. I forgot my pound include. So right now this main.cpp does not know about this A class. So people have asked me, which one do you include? Do you include the a.cpp file? No. That leaves you just the a.h file. And that's actually what you pound include. So just like you have here, you can copy this, copy that, and paste it here. Okay, so now it's the same thing. All this does is it copies the entire contents of this a.h file and puts it in here. So the reason we use pound include is so that we can save on copying and pasting. Let's say we just add a single space for whatever reason. We just put something in here, right? Now, technically this has changed, so it will be recompiled and the C++ preprocessor will notice that change and re-include it and create a new file temporarily that the C++ compiler will compile. Okay, so this time around, once we put the pound include a.h, we're all set.